Hello and welcome to our ZettaScale live webinar. My name is Daniela and I'm working in the marketing department here at ZettaScale. Today I'm here with my colleague Julien Enoch, who is our senior solution architect, and you probably recognize him because he already hosted 2 of our webinars in the past. In this session, he'll be talking about the MQTT plugin for Zenoh. If you missed any of our previous webinars, you can see them posted in the chat in a minute. And if you want to access the presentation slide for this session or for any of our previous sessions, you can see them in the handouts section on the right side of your screen. With that, I'll let Julien start the webinar. Julien?
Thank you, Daniela. Hello, everyone, and welcome to this new episode of our ZettaScale webinar sessions. And today it will be focused on the MQTT plugin for Zenoh. So first, a quick reminder of what is Zenoh plugins. You may have followed our previous episodes where I spoke about DDS plugins, but let's recap what we consider as a plugin in Zenoh. So Zenoh is actually extensible via plugins. We already provide plugins for different connectivity, for instance, for integration with third-party protocol, like REST API, like DDS, like MQTT, but also plugins to integrate with some databases, for instance. We have a specific plugin, which we named the Storage Manager, which allows you as a user to define some storages that will be able to store all publications or a subset of publication of your system in some database technologies. So what is a Zenoh plugin? Actually, a plugin for Zenoh is a shared library. So this shared library is actually just considered as any Zenoh application. It includes a Zenoh session, so you can really develop a plugin such as any Zenoh application. You have your Zenoh session, you can do put, you can do get, you can do declare subscriber, declare queryable, and so on and so forth. But the point is that it shall be first implementing some traits, some Rust traits, because all the plugins in Zenoh are developed in Rust. And those traits are just the bootstrapping of your application that will then give you a session which is directly a session of the router. Because actually a Zenoh plugin is loaded by a Zenoh router. So all the plugins that you may have in Zenoh actually lives within the lifecycle of a Zenoh router. It's loaded by a Zenoh router. And it's loaded either at startup, so you can configure a Zenoh router with a set of plugins to be loaded as soon as it starts, along with all the configuration for the connectivity of your router. Or you can also make the plugins to be loaded at runtime. And this we will see how it can be done through the Zenoh admin space. So how can you configure a plugin to be loaded by a Zenoh router at startup? To start at Zenoh router, the command to start at Zenoh router is Zenoh-D. That's the name of the executable for the Zenoh router. And to this Zenoh router, you can give a configuration file in JSON5 or in YAML format with the option -c. So here we see an example of a JSON file, configuration file. And here we have a set of properties, and the first one, for instance, is all about the router connectivity. You specify the endpoints, remote endpoints to which you want your router to connect to. So if you have another remote router, you want to establish a mesh connectivity between various routers. For each router, you will specify here to which remote router it shall try to establish the connection at startup. And then you have a sections about the plugins. In this section about the plugins, each plugin instance will have its own section, its own parameter. And for instance, here we declare 2 plugins to be loaded at startup, the REST API plugin and the MQTT plugin. In each of those subsets, for REST or for MQTT, you can specify various options which depend on the plugin's implementation. For runtime, how, when you have an already runtime Zenoh router which is running somewhere, how can you make it dynamically load a plugin as a shared library? So first, you need to have your Zenoh router running with right permission on its admin space. So admin space in Zenoh is a specific set of key expression in Zenoh, all starting with @/router/UUID of the router, so the identifier of the router. This admin space by default in the Zenoh router is in read-only. So to be able to, in the future, allow to write on this admin space and then to make the router to load some plugins, you need to allow it to the write operation on the admin space. That's done with this option --admin space -permission RW. And then you can change the configuration of your router, so you can add plugins in your router, just addressing its config space. So here we have the path which is @/router/UID, the path of your router, /config/plugins. And here you have the plugin name. So it will be, for instance, as you can see just below with a curl example, /MQTT. And the value to put here will be the exact same content that you have in the JSON 5. So for instance, here we configure a port, which is 1883 for the MQTT plugin. So yes, this is ready to be able to load your plugin at startup. You can also unload your plugin at startup, just deleting its configuration, and the plugin will be unloaded. So more focusing about MQTT plugin now. You have here the GitHub link on plugin for MQTT. So it's an open source plugin. You can check the code. You can also contribute to the code if you want. That will be very welcome. And this plugins actually comes in two flavors. That's similar to the plugin for DDS that we have. For the MQTT plugin, we implement it either as a plugin, as a dynamic library, either as a standalone executable. So the only difference is that the dynamic library needs to be loaded by the router. The standalone executable is the exact same share library than for the plugin, but it's statically linked into a standalone executable. So just a main operation which statically starts the plugin, which is statically linked. But the configuration will be the same, right? You can use the same configuration for the bridge and for a plugin inside a router. So it's up to you. Sometimes you may want, for instance, to have a router which mixed various plugins. So for instance, to have a single router to interop with both MQTT and DDS and the REST API. Sometimes you only want a bridge from MQTT to Zenoh, so there is no point to deploy a router. You can deploy just a standalone bridge. And the standalone bridge, as any Zenoh application, can be configured to be either in peer mode, either in client mode. So if you recall, you can refer to the former webinar we made to have a distinction between peer and client mode in Zenoh. So MQTT broker, how is it implemented? So actually, it's implemented acting as a MQTT broker. It means that really you don't need to install any third-party broker like Mosquito or whatever broker, MQTT broker can exist. You can use the Zenoh Bridge MQTT or the plugin MQTT as an MQTT broker. So all you need is really your MQTT client applications to connect to this MQTT plugin or to this Zenoh Bridge MQTT. And what does this bridge? Actually, it implements the two standard common MQTT operation on publish callback and on subscribe callback. So what it does is that when receiving a publication in the on publish callback, it simply publish the same payload received from MQTT to Zenoh, reusing the MQTT topic name as a Zenoh key expression. So here we have a MQTT topic name on room/1/temp. And we put on a Zenoh key expression room/1/temp, the exact same payload. So there is no translation of payload format. MQTT allows you to use whatever format of payload you want, JSON, raw, just an integer. Zenoh will just take this payload, this byte buffer, and transmit it into a Zenoh key expression. In the unsubscribe, when receiving a subscription message from MQTT, the bridge MQTT will create a Zenoh subscriber, a corresponding Zenoh subscriber on the exact same key expression, room/1/button. And when receiving a Zenoh publication on this key expression, it simply forward the payload received on this MQTT topic, room/1/button. So quite simple. We have exactly one-to-one mapping between the MQTT topic and the Zenoh key expression. But you know that in MQTT, there are also some specific characters, like the plus, to map, to match one single segment between slashes in the MQTT topic. And this is simply mapped on a star character in a Zenoh key expression, because we have exactly the same semantic here. And for the sharp character in MQTT, which maps a certain number of segments in the MQTT topic, we map this on a star key expression in Zenoh, which also means as a list of segments in the Zenoh key expression. So here, again, something mapping very simple. Now, how about the configuration? What kind of configuration you can have on your MQTT plugin? The first one is the port number and the IP address where the MQTT server, the MQTT broker equivalent, is running in the form of a Zenoh plugin for MQTT. So the Zenoh plugin for MQTT can be started, for instance, by default, it will be started on any interface. It's IP 0.0.0 and port MQTT standard default port, which is 1883. You can change this if you just want to still listen on any interface of your host, but changing the port, you just specify your port. If you want to listen on a specific IP interface of your host, you specify the IP address and then column and the port number. Similarly to DDS plugin, if you've seen the webinar, you can also specify a scope in the bridge, in the plugin for MQTT. So this scope will be a prefix added to all Zenoh key expression when mapping from one MQTT topic to a Zenoh key expression. So for instance, here we scope home-1, a topic A/B/C will be seen on Zenoh as a key expression home-1/A/B/C. It also means that when you have a subscription, for instance, in MQTT on A/sharp, for instance, it's seen on Zenoh side as a subscription on home-1-A-***. Right? It always, even the subscription on the both subscription and publication, are mapped with this prefix. So with this, you can already build a system, for instance, a collection of subsystems which are using internally the same MQTT topic, but on Zenoh, they are exposed with different scopes, so there is no conflict of communication on the Zenoh layer. Then, sometimes it's preferable to forbid some topics to be exposed over Zenoh. Sometimes you want to keep some topics private to your MQTT subsystem, for instance. So for this, we have two configurations in the Zenoh plugin, allow and deny. And those two ones are just regular key expression that shall match either the topics that are allowed, either the topics that are denied. If both allow and deny are set, of course, a topic needs to be both allowed and not denied to be routed over Zenoh, right? We make sure that there is no leak in the data. Note that if some MQTT topic is denied, it's only the denial to be routed over Zenoh. Still, the MQTT plugin allows the routing between two MQTT clients on the same topic, which is denied for Zenoh. So you don't lose the MQTT connectivity because of this deny or allow rule, which only affect the Zenoh communication. So what can you do and how can you use the MQTT plugin? So for instance, you can use it in a case of a decentralized MQTT system. Here we have an example of an IoT system with 2 homes and some sensors, smart sensors at home for temperature, lighting, for a fridge. And we use different scope here, right? Because probably, or maybe the system are using the same MQTT mapping for all their devices, and you may have, for instance, a sensor in kitchen / temperature, for instance, in both home, and you don't want to mix those when exposed in an aggregator somewhere in the edge or in the cloud. So we scope here the 2 bridge to prefix each MQTT topic in Zenoh with a prefix corresponding to the home number. And you can have those bridges connected to a first layer, for instance, a edge MQTT service system, which might be developed, for instance, in a data center in some district, or in the scope of 5G in some MEC deployment for 5G antennas. And then in this scope, in this edge device, for instance, you can also have your own scope, and then you can consolidate all your information, all the data you get from the homes, for instance, and then republish something over Zenoh, and still be able to get all the information to a router, for instance, in the cloud, where you can also have an MQTT plugin if you want to still have MQTT application getting all information from an MQTT system. But you can also have a Zenoh application which can subscribe to all your MQTT applications. And you can also, of course, leverage the other Zenoh plugins, such as a storage manager plugin, for instance, on InfluxDB, that will subscribe to all MQTT publications and store all those MQTT publications in an InfluxDB database. That's a kind of use case that you can use. But there are more use cases. The first one, of course, is more integration with Zenoh. For instance, we have Zenoh Pico, which is a pure C implementation of the Zenoh protocol, and which is able to run off very constrained device, such as microcontrollers. So here, for instance, if you have Zenoh Pico application, they can publish and subscribe to key expressions that will match MQTT publication routed by the bridge MQTT, for instance. And then you can benefit also, for instance, all the connectivity that offer Zenoh Pico, for instance, with serial communication, UDP, QUIC, Bluetooth, LoRaWAN, or all the future transport that we will add in the future for Zenoh Pico, but also for Zenoh. So you see that MQTT by itself is only implemented on Ethernet, TCP, most of the time, sometime on WebSocket, sometime on UDP. But as soon as connected to Zenoh, you get another broad variety of transport that can be used in your system to communicate with Zenoh and with MQTT. Another use case, for instance, is to bridge 2 MQTT systems that are behind symmetric NATs. Usually, behind symmetric NATs, you cannot have a direct connectivity between your 2 systems. But here, you can have 2 MQTT bridge. So each one is acting as an MQTT broker in a subsystem. You interconnect them with the help of an intermediate Zenoh router. And all of a sudden, all your MQTT system is only one wherever your LANs are. They are just bridged via the Zenoh router. If you can configure, of course, the NAT to have at least one which can open a port, you can establish a direct connectivity between the 2 bridges, because they can be deployed, for instance, in peer mode. So you have peer-to-peer communication between the 2 Zenoh bridges. And then you have other use case, which is all about integration. So you can use Zenoh as an integration protocol between all the protocol we can support in our plugins. So DDS, for instance, but also REST API and SSE. So SSE stands for Server Source Event. That's really to be able to subscribe to some publications in a web browser, for instance. And this way, you can get all your MQTT publication directly in a web browser, which is just connected to the REST API, and subscribing to the Server Source Event corresponding to the Zenoh key expression that is published. In the future, we might, for instance, implement a new plugin for Kafka That's something we consider, so you can have integration between Kafka, DDS, MQTT, and so on, thanks to Zenoh. So, time for some demos now. And the first one will be about decentralized MQTT. So let's see how we can build such system. So here, what I will do is that we'll start a simulation of MQTT IoT system on my host here in France. So it will be running on the bottom left host. So it will be a bridge MQTT with a scope home/FRA. On the bottom right, there will be another simulation of a home that I will run in a host hosted in a data center in the USA. So there will be a scope home/USA. It will do the same simulation of publication for temperature and electricity consumption. And both those bridges will be connected to two routers, one in Europe, still in a cloud, and the other one in Asia Pacific. So I think it's in Singapore. And the two routers will be interconnected via Zenoh. And the two routers will also have MQTT plugins, so I can connect directly with a MQTT client into those routers to subscribe to information which are published by MQTT or by any other Zenoh application, for instance. So let's have a look on how we can achieve this. So at first here, I will start my local bridge with a configuration file. So let me just show you quickly the configuration file for this. That's the one, MQTT home local. So here I just specify the connectivity. So connectivity to the router in Europe and connectivity to the router in Asia Pacific. They are not running yet, but as soon as they will be started, this bridge will establish the connectivity to those routers. I'm defining two plugins, a REST API, for instance, if I want to have a local REST API, that can be useful, and also the MQTT plugin. So the MQTT plugin, I define here a scope on home/FRA. And here, I'm denying all the topics containing the word electricity. Why? Because, for instance, I might be comfortable exposing the temperature on my home, but the electricity consumption is something which might be considered as a sensitive information, right? It can allow anybody to know, for instance, if you're at home or what kind of hardware you're running at home, and so on and so forth. So sometimes it's confidential. So here I'm configuring my bridge to only expose everything which is not electricity. So here I will start at first my MQTT simulator. So here I'm using a very nice project I found on GitHub, which is MQTT simulator made by Rafael Damasceno. You can find it on GitHub. And this simulator allows you with a simple config file to simulate some publication on a subset of topics. So for instance, here I have this configuration file. So here I'm configuring the simulator to connect to my local host MQTT broker, which is the MQTT bridge for Zenoh. And here I'm defining 4 sensors on publishing on sensor/home. So 1, 2, 3, 4, with 2 fields in their JSON publication, one for temperature, one for humidity, and then a single other publication, which is electricity, and the electricity with a consumption, for instance, with a random value between a certain defined range. So it's really a quite convenient tool. So let's see at first what I can get with the MQTT Explorer. So another tool just to browse. You probably know if you know MQTT, which allow you to browse what's running on a MQTT system. So here I'm connecting to localhost, and by default there is a subscription on Sharp, so it will subscribe to anything in my MQTT router. So as soon as I'm connecting, I get all the publication. So the 4 sensors on sensor/room and the electricity consumption here. So electricity and topic sensor room / number 4, for instance. Fair enough. Now I'm running a router in the Zenoh cloud. So here I'm connected to the host au.demo.io, and I'm running this Zenoh router with also MQTT plugin. So let me show you here its configuration file. So it's configured also, that's the one. So it's configured also to connect to the one in Asia Pacific and to other routers if I want to run other routers. And it's just running also the REST API on the MQTT port with some other deny topic. And now I can start another MQTT Explorer. And this one, I will connect it to au.zenoh.io. So if you want, you can, if you have an MQTT Explorer or any MQTT client with you, you can also connect to this MQTT plugin in the cloud. And now what I get here, you see, I get the forwarding of MQTT publication with the scope that I configured, home/FRA/sensor/room and the room number. And you see, there is no electricity here because it has been denied by the bridge configuration on my local host. So now let's do the same in the US. So here I'm US East Coast. I'm running a similar bridge. So here the configuration will be with with the scope home/USA. And I'm starting the same simulation, the exact same simulation, but connected to the plugin running on US East, so with the scope. So here, my local MQTT Explorer still sees only the local publication. But if I'm going here up to MQTT Explorer, which is connected to the cloud, I see a new path, a new topic which appeared, which is home/USA/sensor/room and number 1, 2, 3, 4. No, still no electricity. And I can start my second router in Asia Pacific this time and start a second MQTT Explorer. This MQTT Explorer connected to Asia Pacific. I'm connecting. And I also see all the data coming from France and from the USA. Okay. And of course, if I starting a fourth MQTT Explorer, and this one connected only to US East Coast, well, I get only the local publication, and this time with electricity because it's local MQTT publication I get here. So with all of this, I can of course stop any router in the cloud, for instance. So for instance, here Europe is stopped, I'm disconnected, but still from Asia Pacific, I get all the data information I want from my local subsystem. I can stop a local subsystem here, but still I get all the information updated from Europe. So you see here is a simple way to create a fully distributed MQTT system with various MQTT system which can be spread all around the world. And still, I can have connectivity from the cloud or from the edge, right? Because those routers might be deployed in local data center or in the cloud. And I can really access all my MQTT information from anywhere, thanks to Zenoh, with an MQTT application like MQTT Explorer, but also with a Zenoh application, because all the publications are made on Zenoh. So I can also have a Zenoh application which declare a subscriber on the exact same key expression, so home/FRA/room/sensor/room/1, for instance, and I get the exact same Zenoh publication. And now the second example. So the second demonstration will be, maybe you have already seen once if you saw some of my talk before. It will involve this turtle bot that I'm starting right now. So this is a turtle bot used by robotic students, usually for very first experiments with robotic. It's running a Raspberry Pi, and it's running the ROS2 middleware, which is a robotic operating system in version 2, which is based on DDS. So it's using another product, open source product that we make here at ZettaScale that we developed, which is Cyclone DDS. And so this robot has a lot of nodes on DDS nodes inside, which are publishing and subscribing to various DDS topics. So similar to DDS, to MQTT, but with a peer-to-peer mode. So it's really peer-to-peer between various processors inside this Raspberry Pi. And what I will do right now is that on the other end, I also have this Raspberry Pi here with a ZigBee key here. And this ZigBee key is using the same that you may have at home. For instance, it's controlling some home device such as a light bulb or a click button, a push button. And what I will deploy now actually is a simple Python script that I'm running now here on another host. And this Python script will subscribe on Zenoh. So it will not run any MQTT or DDS code, just pure Zenoh code. It will subscribe to MQTT, which are published on a specific key expression named ZigBee to MQTT /device/button. So that will be all the publication from my ZigBee buttons that are translated into a publication over MQTT thanks to this ZigBee to MQTT library, which is a library you might use at home, for instance. It's widely used in Home Assistant, for instance. So all the publication over ZigBee are routed as a MQTT publication or subscription. So my script is subscribing to publication from the button, and when receiving one click or two click on the button, it will publish on another key expression which corresponds to the robot. So here it will publish on bot1/rt/dmcmdvel, and in the robot there is a DDS subscriber that subscribe to this topic and that will receive the command sent by my Zenoh script. And so if I do this with the button, I'm pushing the button here, and you can see the script is sending a command to make the wheel to spin for just a few seconds. So double click, the spin will turn in another way. So here you can see we have an integration with a publication from MQTT up to DDS, thanks to Zenoh, which routes everything smoothly. And for the other demonstration, it will be with this lamp. So on the script, same script, we also have a subscription to the publication of the LiDAR information. So that's published on a topic on DDS named bot1/rt/scan. And the script gets all this LiDAR information. So LiDAR is this small spinning wheel on the top of the robot, which measures the distance between the robot and an obstacle. It will, the script will select the front angle of the LiDAR, will compute an average distance, and depending on the distance, we'll send some command on the light bubble, just publishing over Zenoh on ZigBee to MQTT/device/bubble/set. So the front of the LiDAR is here. So if I put on the front here, you can see it's green. It means the LiDAR is far away from the obstacle. As soon as I get in front, the light bubble receive a command to turn to red via the Zenoh and via the MQTT bridge. Okay, and that's actually the conclusion of this quick webinar on MQTT. So thank you for your attention. And actually, if you want more information, of course, you can come and get more information on our Zenoh website. You can check the code and moreover the code for the MQTT plugin on our Eclipse Zenoh GitHub. You can find it. And if you want to contribute to it, because it's not still not fully compliant with regard to all the possibilities that offer MQTT, you're very welcome to contribute, and but we'll of course try to make this MQTT plugin to evolve very soon. And if you have any question, join also your Discord server, and we have also, of course, as Daniela mentioned, our webinars available on YouTube, and this one will be available very soon. Thank you. And yes, if you have any question, you can shout any question right now. And I see actually there are some questions. So let's see which question do we have. So the first question is from Andre. So Andre, I've tried the MQTT plugin with Zenoh. How does retain MQTT message work? Well, at first, right now, currently it doesn't work because it has not been implemented yet. I hope I will be able to implement this very soon. The implementation I foresee is relatively simple. It will leverage some in-memory storage inside the MQTT brokers themselves. So we will just embed also in the same plugin the functionality of storages. And so you can have, for instance, in Zenoh, we have the equivalent of a subscriber which can do a query. So we name this in Zenoh extension in Rust, querying subscriber. So you will be able to get the retained message along with the current subscription. And of course, a remote bridge, which is bridging to MQTT, will also be able to get this information to republish the retained message in its own MQTT subsystem. Other question from Andre, does Zenoh need to configure storage nodes for that to work? So in my plan for retain messages, there will be not the necessity to configure the storages because I plan to embed the storage within the MQTT plugin itself. But of course, you can still have your own storages defined along with the storage which will be embedded with the MQTT plugin. If you have some other idea or if you would like to contribute to this work, feel free to contact me and we can discuss details in Discord or in GitHub. Then a question from Juan. Hello, thank you for your nice presentation. Thank you, Juan. I would like to know how MQTT plugin manages the QoS if it is supported and how it transforms it into the Zenoh features. So that's also QoSs from MQTT are still not yet implemented in Zenoh. Also something to do. The way that will be implemented is quite straightforward. In Zenoh, we also have reliable mode. So the reliable mode will correspond to QoS level 1. And for QoS level 2, we might have some specific addition for this to support QoS level 2, but I can discuss this in detail because we need to figure out exactly how to map them in the future. And last question is from Laszlo. Laszlo, if I have a Swagger description of REST API communication, can I bridge it to MQTT with the Zenoh bridge? So not Swagger. Don't know this Swagger specification. I guess it's a description of a REST API. So as soon as yes, actually you can route any communication from the REST API to MQTT, right? Because any communication with the REST API of Zenoh maps to either a put, either a get on Zenoh, right? HTTP put on the REST API will trigger a Zenoh put on the same path. And if you have a MQTT bridge, that will create a publication on the same MQTT topic name than the key expression corresponding to the URL on which you did the put via MQTT. So yes, you can really do this way. And in the other way, if you want to subscribe from the REST API, well, the only subscription we have is with, it's not really REST, but it's server source event. So you can subscribe from HTTP. It's a long polling mechanism. And any publication from MQTT will be routed to an equivalent Zenoh key expression. And that will also be forwarded to any server source event subscription that might be declared by any web browser, for instance, in a system. So yes, actually, if you look at the demonstration we have with the robot that I just showed, you can also see that we, in some past presentation I made, I think it was presentation with the construct in robotics, so a very long interview I made last month. But at the end of the interview, there is a full demonstration similar to the one I just showed with the robot. And you will see there is a simple web page using the REST API to perform both publication and subscription to Zenoh. And you can see in the logs that it receives also some messages from MQTT. So all the messages to change the color of the bubble, for instance, are received in the browser via the REST API. So I don't see any other questions. So thank you very much for your attention. And if you have any other question, of course, feel free to contact us, to join us on Discord, and I'll be here to answer. Thank you.